this class shifted to
Okay.
115 to 215?
Yes, I will talk to later about this matter. Okay, I just taken my class after the time
Oh,
discuss. Okay, so good afternoon, my dear students. So today I am discussed about the power supply in the electric traction. Okay. Practical scenario of our electric locomotive. You can think like that. I am always telling about the traction system in the Indian railways. Okay, not other railway systems. Like you know that in throughout the world, different railway systems are there. Okay, but I am much more focused on the Indian railway system. Okay, so that's why beginning of my session I just going to clear about it. Otherwise, there may be sometimes confusions. Okay, so as of the different countries, so different conventions normally followed. But in our cases, I am normally followed by the Indian railways system. Okay. So from the diagram, okay, so here I think all of you will be able to see the basic diagram of basic diagram of the power supply in the traction. So you know the conductor. Okay, so you know the from the diagram it is the diagram of pantograph. Okay, so pantograph means you know that one, it's a jet shape things you can see from the you can see from any of the above, means any of the roof side of the locomotive. Okay, in any of the trains. Okay, so that is normally known as pantograph. So pantograph having some means segments. Okay, so it is look like a Z-shaped thing. Okay, Z-shaped object. So it having three most important parts. First thing is your contact strip. Okay, so contact strip. Second one is your horn, and third one is your pantograph arms. Okay, so here it's the diagram of the pantograph and its parts. Okay. So contact strip means what happens if you see the detailed structure of the pantograph in any of the workshop. So you can see there is a big screen. Okay, big screen is there that is holding the pantograph within the roof of the locomotive and the overhead conductor. Okay. So the screen is there for maintaining that for maintaining the minimum gap, okay, or no contacts, okay, maintaining the contacts in between the contact strip of the pantograph and the wire. Okay, if there is any gaps, okay, then what will be the problem? What is the necessity of that strip? Okay, that I am going to tell. Okay, so if there is any kinds of gap, then main problem is that that overhead connection voltage is 25 kV. Okay, and what is your potential of the chain or locomotive? Normally, you know that it is touching the earth. That means it is earth potential. You can say like that it is in zero potential. Okay. So if there is any gap between the pinto contacts, means contact strip of the pantograph and conductors, means for which type of conductors? There are normally two conductors you can see in the overhead connection. Okay, one is contact wire where the pinto is touching with the conductor. Another one is called the catenary. Okay, so if there is any gaps in between the catenary, in between the contact wire and the pantograph contact strip, so there is the chances of the breakdown of the air in between of them. Okay, so unnecessary flashing you can see. Okay, so if unnecessary flashing will be there, so definitely it may reduce the means it may accelerate the aging effect of that wire as well as your pantograph contact strip. Okay, so you should look into this matter. That's why the screen is there. Okay, and the special type of orientation is there. Okay, so for the lifting of the pinto, okay, you know that is it is jet set. So definitely there is a automatic system. So you can lift it the pinto from rooftop of your locomotive to most of the, the height, you can change the height of the pantograph, that I'm going to tell you. Okay. So how to change that height of the pantograph? So definitely there is a motor. Okay, so that motor can take place for the changes of the air pressure. Okay, if the hydraulics are there. Okay, the hydraulics are there, and if you compress that hydraulics, means if you change the air pressure of the hydraulics, automatically it can control the movement of the pantograph. Okay. So you have to think the most important parts. Okay. So horn means, what is the purpose of that horn? So your pantograph, the purpose of the pantograph is collecting the current. Okay, collecting the current from the overhead system. Okay, of the overhead connection. Okay, if the horn means, it looks like a one kind of isolator. Okay, so initial isolations also be there, as well as some protection system also important. Okay, and pantograph arm means, the purpose of the arm means the basic features of the arm to holding up the cables. Okay, the holding up the cables, that pantograph is collecting the currents. Okay, that contact strips are normally collecting the currents. Okay, so from the strips, what happens, the conductors are connecting from the contact strip, through horn. Okay, then through pantograph arms. Okay, then what happens, it can, then that if you see the rooftop of the locomotive. Okay, so some of the isolators are there, not isolators, only one isolator is there. Okay, and in between the isolator and there is a another cable. Okay, after the isolator. Okay, before the isolator, the conductor is coming from pantograph head top, means contact sheet, then horn, then pento arm, then the conductor will be moving towards the isolator. Okay, isolator means it's an manual isolator as well as the circuit breaker. Okay, manual isolator and the circuit breaker. After the circuit breaker, you know that there is a conductor, special type of conductors are there, means cable. Okay, not conductor, like that cable conductor. Okay, so cable is there, that cable is taking from the current from your circuit breaker. What type of circuit breaker normally we are using? Air blast circuit breaker. Okay, for and vacuum circuit breaker. Okay, so right now other circuit breaker may be developed. Okay, so technology has changed with the time. Okay, so maybe other type of circuit breaker also be there, like SF6 circuit breaker. Okay, but that may be more costlier. Okay, so you have to design the system which is cost efficient. Okay, so cost efficient configuration is mostly needed. Okay, so then what happened that then it is directly coming, that after circuit breaker, the cable is directly coming to the inside of your motor coach. Okay, so in locomotive, you know that inherently that body means, that inherently it's an big structure. Okay, that locomotive, so there is a motor coach. Okay, so that directly motor coach means, in the motor coach the transformer is there. Okay, directly that 25 kV voltage is directly coming to the transformer in your inside of the motor coach. Okay, then I am coming later. Okay, what happened after that? Okay, so if you go for that EMU system, okay, EMU system is electrical multiple unit system. So those are traveling in the eastern railways. Okay, as well as in Mumbai and different places like Delhi. So local trains already there. Okay, but in sometimes that mini. Okay, so that there is multiple pintos are there. Okay, as per the number of coaches. Okay, as per the number of coaches, you have to decide if it is called the electrical multiple unit. So multiple coaches are there. Okay, so you have to decide what will be the capacity of individual motor coach. Okay, what is the capacity of individual motor coach means, like one motor coach, one motor coach consists of some of the traction motors. Okay, normally the number of traction motor is urban transportation in motor coach having the four wheels in first side and back side another four wheels. Okay, means in that case, what will be the It drives the two wheels will be divided to traction motor. Another means front side four wheels, back side four wheels. For only for one coach, okay, only for one bogie. In locomotive, okay, in locomotives individually front side there are three wheels, three pair of wheels, okay, three pair of wheels. So one motor is dedicated for one pair of wheels, okay. You can see from the locomotive having six wheels from your side means there are six pair, only one wheel any means any motor or any it's not the balance system now. So six pair wheels are normally you can see in the locomotive, but in your electrical multiple units means EMU you can see there are four pair of wheels. Okay, so four pair of wheels means for individual pair having two wheels. Okay, so only one motor is dedicated for one wheel, one pair of wheels. So two motors will be dedicated for two pair of wheels. Okay, so you can see there are four pairs of wheels. Okay, so individual pair will be given by individual traction motor. Okay, so directly you know that in there is a transformer. So transformer is responsible for it having some of the windings. Okay, so one winding is dedicated for the traction motor purpose. So in our electrical multiple units having normally you know that for 12 coaches bogie, sorry 12 for 12 bogie EMU you can see there are normally four Pinto means four motor coaches are there. Okay, four motor coaches. Other bogies have the wheel. Okay, but that will not be connected with the traction motor. Okay, so that will automatically moving. Okay, that will having some brake. Okay, braking system is implemented for each and every pair of wheels. Okay, no problem. But only motor coaches having the traction motor. Okay, so how do I identify the motor coaches in the electrical multiple unit? So you can see the top means rooftop of the bogies. Okay, those bogies having the pantograph, that means that bogie have the traction motor. Okay, that bogie has the traction motor. And how much number of the traction motor? That you need to calculate that what is the total number of pairs or individual bogie. If there are four pairs of wheel, so four traction motor. If there are three pairs of wheel, so definitely three traction motor. Sorry, six pairs of wheel, so there are six traction motor. So normally in electrical multiple unit and the memo having four pairs of wheels. You can check anywhere. Okay, means when you are waiting in the station, okay, you can check it. But normally what happen in your place means Raurkela or other places. So memo are not means memo are not normally you cannot see that memo. Memo is only you see that passenger trains. Okay, so passenger trains means definitely it's having the loco type of engine. Okay, but in memo means you can see in Eastern Railway, you can see it in your Mumbai terminus means Mumbai railway terminus. Okay, special places, some of the metro cities you can see over it. Okay, in single word I can say like that. In metro city you can see electrical multiple unit. Okay, where that passengers are traveling from 100 kilometers away to go to attend their job place. Okay, to go to their job place means in the metro city. So they need to travel either 100 kilometers, 50 kilometers. That's why they totally depends upon that electrical multiple unit. Okay, so individual motor coach can drive another two additional motor coach. Okay, so if that electric multiple unit having four motor coach. Okay, so how much number of bogie you can accommodate over there? So four into three. One motor coach is capable to drive three bogies. So how much if there are four motor coach? So it can drive maximum 12 bogies. So normally you can see in Eastern Railways or other places related to the metro city means EMU you can see. So there are normally 12 bogies, 12 bogie EMUs, okay, or 12 bogie memo. That means individual you can see the number of pantograph is connected in with the regular intervals. Normally after means one motor coach means three bogie it may be connected with one motor coach. So you can see after three coaches, so fourth one again one pinto is there. So you can calculate it, no problem. Okay, it is normally see it is normally observed in the common structure. Okay, so I think you are able to understand the pantograph. See, so here you can see the overhead line catenary. Okay, so line catenary means what happened? You can see the from the structure. Okay, so two wires are there. Okay, so it is called upper one. So upper one, this is directly connected with the insulated with the ice. Sorry, insulated bar. Okay, insulated bar means that bar also connected with the RCC pole. Okay, you know that insulators are there. Okay, so that point directly, you know that in power system you can see like that RCC posts are there. Then some of the shackle types of insulator, or sometimes string type of insulator. So here you can see some string type of insulator here. Okay, so that string type of insulator that connect that holding the your catenary wire. Okay, so catenary wire, what is the purpose of the catenary wire? So you will provide the electricity to the catenary wire. How do you provide the electricity to the catenary wire? So you know that beside of the railway track, okay, if you see minutely, okay, you can see sometimes the traction substation. Okay, do you heard that type of terminology, the traction substation? Is any students heard about it? Traction substation? Yes or no? Please give your response. Shankal, am I audible?
No, sir.
I am not audible.
No, you are audible, sir, but no, we haven't heard.
Anybody do not heard about the traction substation?
No, sir, it is the first
Okay, so
time.
I am going to tell you. Acha, okay, first time in machines, did you heard about the Scott connection? Shankal?
Yes, sir.
Yes, sir.
Yes sir, no, what is the purpose of Scott connection? Anybody can tell me? Any of you? Tell me. Any of you, please tell me, what is the purpose of Scott connection?
Three phase to one phase conversion.
A three phase to one phase or two phase?
Yes, two sir.
Two phase.
Two phase, sir.
Okay,
Three to
three
two.
phase to two phase conversion. Okay, so first time what happened? Scientists Scott that's why first we convert that three phase to two phase conversion with the special type of transformer. Okay, so that's why you know that type of configurations. Okay, that type of configurations, winding configuration of the transformer is known as Scott connection. Okay, that Scott connection is well used in Indian railways. Okay, so where it will be established, you can see if you travel different places, you can see sometimes it is written like that. That means traction substation. Okay, so what is the purpose of traction substation? In traction substation, you are using the transformers which having the Scott connection configuration. Normally, you convert that three phase AC to two phase AC. Okay, that is the motivations of the traction substation. And you know the rating plate of the substation, it is mentioned that it is 132 kV slash 25 kV. Okay, so that means there is a stepping down of voltage. So you know that 132 kV means that feeder is directly coming from any of the transmission substation. Okay, you know na, you know, I think all of you aware about the different gradations of the substation, like generating substation, transmission substation, then distribution substation. Okay, so especially the traction substation is designed only for that railway system. Okay, where you are directly taking one feeder from transmission substation, which is in that substation, in traction substation, that 132 kV is stepping down to the 25 kV. Okay, so why 25 kV? Basically, that connections. Okay, you know the connections of the traction system means the source of the traction system is for design for 25 kg. That's why you have to get the 25 kg. So how to get it? So you are normally getting it from the traction substation. Okay. So where you are using the special type of transformer that is Scott connected and can convert 3 phase 132 kV to 2 phase 25 kV. So for the outcome of the substation means you know that it's a 3 phase connection. Okay, it's a 3 phase. Okay, so input is in the transformer input is 3 phase, but output is 2 phase. Okay. So directly the outcome of the transformer is connected. Outcome of the means output feeder. Okay, output feeder of that transformer means 2 phase. It is directly coming another substation. That is your nearby. That is you can see when you are traveling with the train. Side of your railway track, here you can see it is written like that SSE slash something values are given. That is also small type of substations. Okay, so that substation is normally consist of some CT. Okay, some CT as well as some PT. Okay, for individual phase line, the CT is directly connected with the substation, and for the PT again it is some directly coming with some. In CT it is connected series with the system, series with the line, and PT always maintaining how much voltage is there. Okay, so what is the purpose of the PT? To maintaining, to calculating the how much voltage level is there in your line. Okay, basically what happens? It's a long line transmission na, with your less voltage, means it is 25 kV voltage. Okay, so normally in our distribution section, we are in our city or in our town, we are normally means circulating 11 kV line. Okay, so 25 kV line domestic purpose means with your domestic substation line. So what happened? There is a unnecessary, there is a chances of the unnecessary potential drop. Okay, basically you know that conductor, and all of you please mute your microphone except me, except myself. Okay, so please mute your microphone. Okay, so unnecessary noises are coming. Okay, so you know that that line having some current value is comparatively less. Okay, so definitely current, you know that power is normally maintained, so current rating will be high. Okay, so that's why special type of contact wire you need to be used. Okay, so normally you can use ACSR contactor with having some special, with having some number of, you know that ACSR conductor having one central line that provide you the mechanical strength, and surface conductor. Okay, surface conductor that provide you the, that is normally carry the currents. Okay, basically you know that due to the skin effects. Okay, due to the skin effects, the AC currents normally travel. Okay, normally passes through the conductor with the surface side conductor. So that's why you know the multiple number of conductor you can make it in ACSRC form. Okay, so and in between that line, so it having some steel reinforced conductors that provide you some mechanical strength. Okay, so here you know that the insulator is there, and you know that catenary wire. So catenary wires are normally you fed that power. Okay, you fed that from traction substation to the just beside of your railway track substation, Okay, so from that railway substation you are directly putting that line to your catenary wire. Okay, so catenary wire all the time it's provided with the mechanical strength, and it's maintain the voltage profile of your main line electricity. Okay, so another wire is there. Okay, so that is the just beside of the catenary. Okay, so that is called the contact wire, where your pento strip, that pento strips, you can see that pento strips are touching here. Okay, so the pento strips all the time is touching here, so that wire is known as, the name of the wire is called contact wire. Okay, I will be making the contact with the pentograph strip, so stripper, so that's why it is called contact wire. And in between the connections of your catenary wire and the contact wire, who will take care about it? So dropper. Okay, so dropper is holding the catenary wire with your contact wire. And the another purpose is there of the another purpose of the droppers is to provide the electricity from your contact wire to from your catenary wire to contact wire. Okay, so now what happened, the long line transmission is the normally long line transmission is related to the transmission substation. Okay, but in this case in railway track, again some long line transmission is there with the very less voltage level compared to your normal power system voltage. You know that normal power system voltage is 132 kV for the transmission purpose, but here it is only 25 kV. So definitely ATC loss will be there. Okay, so it is called ATC loss. I think all of you heard about this term ATC loss. Okay, so due to the ATC loss, after certain time, what happened? That potential drop you can observe over there. So who is maintaining that potential drop? So another substation is there. You know that pole mounted transformer. Okay, sometimes you know that pole mounted transformer. All the time you can see the beside of your railway track. Sometimes you have to look into that matter minutely. Okay, I am telling you right now, so you just try to realize that problem. Okay, when you are traveling after sometimes with your train, so you just notice all those things. Okay, so you are end of the day will be an electrical engineer. Okay, so you have to think the individual purpose of that electrical individual segments that is related to the electrical science. Okay, you have to know how it will be, how the structure of the tower, why it is look like that. Okay, what is bundle conductor, how it will be look like the. Okay, what will be the nature of the practically how it will be look like the bundle conductor. Is the conductor of the means in your distribution line conductor, is it same with your transmission line conductor, means transmission or generating or distribution substation bus conductor, is it same with your normal distribution bus normal distribution conductor? If it is not same, is there any other name? So definitely that other names are there. Their name are different names are there as per the current and voltage rating. Okay, so the name are zebra, panther. Okay, so that is very commonly used in our substation for designing the transmission line. Okay, so why they are specially designed for very high level of voltage as the current. Okay, normally 5000 ampere. The panther or zebra, the rating current rating is different. Okay, so as per the rating, so they can able to carry huge range of current. Okay, as well as the huge voltage they can maintaining that amount of potential drop of huge voltage. So that's a special conductor you have to use. So you have to practical problem you have to realize. Okay, so that is beside of your daily applications, daily uses. Okay, so you have to keep open. You have to keep eyes open. Okay, all the time and try to see. Okay, when you are traveling, so you know that transformer is known as booster transformer. Okay, what is the purpose of the booster transformer? The booster transformer normally installed after regular interval of your catenary, just beside of your catenary and the contact wire. Okay, so after some time, so it will be boosting up the current level of your catenary. Okay, so all the time current level should be maintained. Okay, if the current level has dropped, so definitely the loco or your EMU cannot able to take that amount of current from the pantograph. So the traction motor rating, if such amount of voltage is not there, so low voltage is coming to your system, then what will be the problem? You know that in protections, okay, in power system protection, we are much more aware about the low voltage protection for the machines. Okay, so you know that not like machines, low voltage protection especially important for our motor. Okay, so why it is important? You know that especially that motors are designed. You know, if you see the rating of the generators are totally different with the rating of the motor. You know that the rating of the motor is morely trust on the active power rating. So we are normally telling that that is 1 HP motor. Okay, that is 5 kilowatt motor. Okay, all the time we are telling about the kilowatt or the HP. So these two are the related to your active power rating. Okay, not for the reactive power rating. But in case of generator, we are telling like that 5 MVA. Okay, 5 MVA power generator which having 0.9 power factor. Okay, so again, field excitation is there, so power factor is definitely important for the generator. So I think this question is already covered in the motion. So same thing I am not going to repeat, but you have to maintain that voltage level. Okay, if the voltage level is reduced, then low voltage directly coming to your across the motor. If motor having low voltage, so what happened? All the time you need to maintain the power. Okay, so low voltage means current will be high. So we know that current high means I square loss will be high. So current high means I square loss high means I square T. Again Joule's law. Okay, so huge amount of heat dissipation will be there, and that may reason for the burned out of your means that may cause for the that may cause insulation breakdown. Okay, if you go any of the workshop, you can see normally we are using the paper type of insulator, oil impregnated paper. Okay, not directly paper, so oil impregnated paper. So oil impregnated paper means paper will be immersed to the oil. Okay, so that insulation we are normally using. So that is the purpose of the booster transformer. Okay, and you know that pentograph is taking higher potential. So another return path also be required. So who will be the responsible for the return path? The return path is your rail. Okay, the railway wheel. So that potential zero potential is coming from the wheel. No? So that is another portion is directly connecting to the. If you see some of the portion of the railway track, that is directly connecting with the wire and the ground. Okay, means neutral is connected through this part. Okay, so the who is the returning path? Railway track will be your returning path of the substation. Okay, so you know that in our generations we did in the power plant. Okay, so that ground. Okay, so that ground is in generating station. The ground is normally happened. Okay, so ground is normally due to the special type of transformer. Okay, you know that the zigzag transformer configuration is there. That type of transformer is called as earthing transformer. Okay, that earthing is done with the earthing transformer. And why it is did? Why it is did in your generating station. Okay, so the transformer is directly earthing the supply. And another return path. Okay, where it will be observed in the neutral. Okay, in the neutral of your pole mounted substation just beside of your house. Okay, you know that in the just beside of your house, another sometimes in your locality you can see some of the transformer are there. Okay, that is pole mounted transformer. Okay, that transformer is your DY11 type of transformer. DY11 means it is delta connected. So first generation is in your star. Then that star to delta configuration is done in the generating station. Okay. Then delta to delta transmission, delta to and throughout the transmission, all the time you are using delta configuration. Okay. Then that delta is coming from transmission section, transmission substation to distribution substation, again distribution substation to your locality pole mounted substation. Then again you are converting the delta to star configuration by using DY11 substation. That is distribution. That is the rating of that substation means rating of your pole mounted substation is normally 100 kVA. Okay, so normally 100 kVA. Okay, so as per the total number of houses connected with that substation. So again that DY11 means input is your delta and output is your star. Okay, so star means RYB is there, another neutral. That neutral is connected. That means that neutral is directly grounded over there. So that one ground is your generating station, another ground is your locality. So the return path is your R. So the total connection is total path is closed. Okay, so you have to realize such better. Okay, so that is our real power system. So we need all those power system, load flow analysis, everything that is very important, definitely. But in reality, when you are working with some laymen, okay, so after getting some BTech degree, you will be the graduate trainee. So the graduate trainee or graduate manager, you will be joined as a assistant manager level. Okay, so you have to work with some laymen. Okay, those having they don't have any lot of technical knowledge. Okay, you have lot of technical knowledge. Okay, but they have the industrial exposure. Okay, they did everything without having lot of good technical knowledge. But you have to overcome. You have to deal with them. Okay, otherwise they will underestimate you. Okay, they told you that sir, taking the BTech degree from big institute, reputed institute, reputed, but you don't have such a means real time exposure. But you have to deal with them, so you have to from the you are in almost 6 semester means you are almost the verge of your completion of your BTech degree. Okay, that means right now you are mature enough to realize all the real time problems. Okay, so you have to realize all those real time problems and is going on. So that is very important for your placement job as well as means handling with the other person, means handling with your subordinate. Otherwise, they will initially all will have faced such type of problem, but after some time, after 6 months, they will be mature enough to dealing with this person. Okay, so who that you know that after sometimes the railway path also been connected means with the grounded. Okay, so you are not directly grounded means it having some earthing processor there. So directly how do you make it earthing? Okay, so you have to dig one big hole. Okay, then huge you know that huge earthing rod is there. So you have to give some salt. Okay, then you have to put that earthing rod, then that big hole will be means poured with some salt everything. Okay, so making that path will be minimal resistance. Okay, so that's why there should not be any potential drop in between that earthing. Okay, so still there is a potential drop. Okay, so as per the level of earthing, the potential also will change. Okay, normally it is 0.4 volt and the resistance is very low. Okay, so we are using that measure for measuring that earth resistance. Okay, that measure is discussed in that instrumentation class. Okay, so the process was there, standard process was there. So you can go for that when you are doing in your measurement lab. I think that measure experiment has done. Okay, so that return part you can get it. Okay, so that poles are the another important thing is not showing in this railway track, I mean, in this picture. So one big weights. Okay, after some interval you can see some weight is coming, means weight is there. Okay, so that give you the tension. Okay, that maintaining the tension of your catenary wire. So otherwise what I mean, the catenary wire having inherent weight. Okay, so inherent weight means it is always try to sag. Okay, you know that terminology sag in power system. So it having some inherent weight. Okay, so all the time it is try to sag. So prevent that sag, you have to mount. Okay, you have to mount some load. Okay, you have to mount some load that also be there in the pole. Okay, that is not showing here. Okay, but it is also important. Okay, so you can also check it when you are traveling. So after some time, you know some big type things are always cooling down. Okay, always cooling down from your pole side. Okay, two things you can see. One is your boosting transformer. Another thing is your the cooling down type of load. Okay, that provide you the tension of your catenary wire. Okay, so that is also very important. That thing is also important. Okay, so you are I think you all of you able to understand that portions. Okay, so that's why that returning path, then return wire is there. So two types of substation I am telling about you. Traction substation. Another thing is your beside of your railway track, some substation which having CTPT as well as means sometimes what happen if it's a long line transmission. No? Sometimes any LG fault is occur. How the LG fault will be occur? Line to ground fault is occur. Any huge storm is there. Okay, due to storm, sometimes some tree is coming out. Okay, it is cooling out and directly just fall down in your catenary and the catenary wire. So again, it will be directly connected with the earth as the tree is directly coming. Means the tree is coming with the storm and it is directly fail into your system. Okay, in your wire system, then huge fault will be there. So bypassing. Okay, why the substations are important? For cutting down some of the portion electricity. Okay, and there is some another issue you can see when you are traveling with some electric multiple units. Sometimes what happens when the substations are there, suddenly the power supply of the train, okay, power supply of the train or EMU is switched off. Why? Basically, there is a mismatching of the frequency. Sometimes what happens? Different power generating organizations are there. Okay, who will provide you the electricity? Okay, who will provide you that 132 kV supply. Okay, so sometimes what happen, all are trying to maintain the standard 50 hertz, but sometimes what happen, the synchroscopes always there. I think all of you are aware about the synchroscope. Okay, so synchroscope, still there is synchroscope, but sometimes there is a mismatching of the frequency. Okay, plus minus 5% normal convention. So if there is a mismatching of the frequency between joining of the two lines, okay, so that may cause some unwanted system noise, okay, unwanted system oscillations, okay. So as there are a lot of RC circuits are there, okay, so there is a unwanted oscillations are there. Okay, that's why at that time the switch off, that means the driver of the locos, okay, they are directly switched off the power supply. Okay, switched off that power supply from the Pinto to your system. So at that time, who will take responsibility for the emergency power supply for making the train movement from this dead zone portion. So there is a battery. So there is a battery is there. Okay, you can see just below of your locomotive or just below of your train rakes. Okay, you can see different box shape thing. Okay, one thing is the smoothing reactor. Okay, SR. It is written like that, SR. Okay, sometimes it is written diet bridge. Okay, so the conversion of the diet bridge of the traction, that also been discussed in my future lecture. Another thing is that battery pack or battery bank. Okay, so that battery bank all the time it will be charged from your overhead lines. Okay, and sometimes that frequency mixing zone, that portion, when you are switched off your main tractions or isolating your main traction system with your Pinto, so at that time who is responsible for emergency electricity and the emergency tractive effort or traction motion, so that battery pack will be took responsible for maintaining the traction. Okay, maintaining the steady state speed for the few of the motion. So totally after some time it is not possible, but maybe some emergency reason, emergency portion, it will be taken care about that battery pack. Okay, so I think you are able to understand. So now what are the different types of overhead catenary? That is called the catenary. It is called single, and that you say things you know, it is called catenary. Okay, so that catenary also been there in power systems, sag and catenary, the expression of the catenary equation. So from there the terms also becoming the catenary. And you know that droppers, okay, that droppers, that straight lines are there, it is called the droppers. Okay, and that's not straight line, that perpendicular line, you can see that is called dropper, and horizontal line is called the contact wire. That wire is directly connected with your pantograph strip. Okay, so it is called that simple catenary. Three types of configuration you can see: simple catenary, then stretched catenary. Here you can see that droppers are different, and last one is your compound catenary, that is connected with the simple catenary, combination of the simple catenary and the stitched catenary. Okay, so stitched means you can see like the stitch like that way. Okay, so C configuration is normally observed in our Indian railways. Okay, so then control of the DC traction motor. So two type of controls are there: rheostatic control. Another one is series parallel control. So again, what do you mean by the rheostatic control and the series parallel control? So normally what happens in you know that in train means you know that one, that braking. Okay, so rheostatic braking. Okay, then plugging concept is also be there. Okay, so sometimes train may come forward, sometimes train may come backward also. Okay, so that's why these two configuration is most important. One is called rheostatic control, that is normally used for what? That is used for rheostatic braking, means dynamic braking. Okay, or you know that rheostatic grid line means, you know that contact contacts are there. Okay, that all are the resistance. Okay, variable resistance that is directly connected series with your armature, and you know that field coil also connected series with your armature. So you know why? Because we all are aware about that in DC, in traction motor normally DC series motor is used for the traction purpose. For why? So very less speed is having huge torque. Okay, so very less speed is having the DC series motor having huge torque. Okay, which can overcome the huge torque. Okay, so why? So basically, less speed means when the locomotive is just try to move. Okay, so it have to overcome the static friction. Okay, it has to overcome the static friction. Okay, what is static friction? In single word, you are aware about the terminology friction. Okay, you are aware about the terminology friction. Okay, static friction. It having huge dead load. Okay, and all the passengers are traveling over there, so it having huge dead load as well as some payload. Okay, so we have to overcome the payload and the dead load. Dead load means the inherent load of the system. Okay, that means the moment of inertia. You have to overcome the moment of inertia. So normally when it will be stand still, so it is always try to stand still. That is your moment of inertia. When it will be running, so definitely it is always trying to in the moment of inertia. So Newton's law, I think so. Okay, so all the times it is try to overcome means it is dead load as well as the payload. Payload means that important things. So important things means if the person or passengers are not traveling with the train, if the goods are not carrying with the train, so how the government generate their revenue? Okay, so definitely that is called the payload. That means the load is related to your income basis or it is necessary. You have to give it necessary. That payload also very important, also very familiar term in satellite. Okay, so in satellite designing, all those relevant issues. Okay, so in that case, we know that is dead load. Okay, you know that dead load is very common terminology. So when train you are going to be brake the train. So normally air brake before the air brake. Okay, so before the air brake you have to go with the electric brake. Okay, so electric brake means normally three types of braking you can see. One is called dynamic braking, okay, or the rheostatic braking. Sorry, one is rheostatic braking means you are directly remove the supply and dissipate the entire energy through the resistance, high resistance part. Okay, that is your registered grid in our railway system, which is known as registered grid. If you need higher range of means totally stop your waste all the electrical energy through this register path. So you have to connect all the contactors. Okay, all the contactors you need to connect. Then what happened? Sorry, I am telling wrong. Okay, if you want very less dynamic, very less rheostatic braking or rheostatic braking in this case, so only one contact you have to open and rest of the contact you have to close. Then what happens? So only current will be dissipated, current will be pass through this resistance first, then this portion will be shorted. Okay, if the contact is closed, means this portion will be shorted. So most of the current always try to flow the least resistance part, and again it will be coming back to the supply. So for the less dynamic braking, for the less rheostatic braking, so you have to open only one contact. Okay, only one contactor. Okay, so if you go for the more rheostatic braking, so two contactors. So if you totally want for total rheostatic braking, so you have to open all the contacts. So that is your rheostatic control. Another one is the series parallel control. Okay, series parallel control means, so sometimes series, if both of the motor are in series means what? Motor are dealing with the huge voltage. Okay, so current is less. Okay, so if the load, okay, so you know that load of the system is directly related to your current carrying capability of the motor. If there is huge load, so definitely both of the motors should be connected in parallel. Okay, so voltage is fixed, but load is more. So both of the motor can distribute. Okay, can split the total current individually. Okay, but if the voltage, if the load is less, but high voltage operation is there, so both of the motors should be connected series. Series means voltage will be distributed in between two motors, but the current will be same. And parallel means voltage will be same, but the current will be distributed. For high load operation, you are normally go for the parallel operation. Okay. Another one is that is given, that series configuration, parallel configuration, and transitions. Okay, so series to parallel configuration is there, that is called the transitions. Okay, so normally we are going for it for the tractive effect. Okay, means if you see the speed curve characteristics, okay, of the or the speed time characteristics of the motor. So first interval you have to go for series or parallel. Okay, gradually you have to change that one. So that portion again I will be discussed in my future class. Okay, basically traction is a very huge vast area. Okay, so it will take at least I will much more focused about the traction at least 2.5 minimum 3 weeks. Okay, so that's why one by one gradually you can understand. Okay, so traction is very important topic, as well as very means lot of interesting portion is there. Okay, so gradually you can understand the methods. Okay, now we are going to control the DC traction motor with the field weakening method. Means you know that in DC series motor, the field weakening means you are in means lifting your speed beyond the base speed. Okay, then you can go for that field weakening method. Then that rheostatic grid line. Okay, that rheostatic grid line is there with the series of the field. Now the field coil is connected with the parallel path. Field weakening means field you need to reduce the flux line, but reduce the flux line should be greater than of your critical flux. Okay, if the flux is less than of your critical flux, so you can understand that the magnetization force, okay, the lines of force will be less. Okay, then motor will be stopped. Okay, that you can go up to that motion, that portion of the field weakening, that flux value should be greater than or equal to the critical flux. So critical flux line you have to maintain. Okay, so parallel resistance is connected with the field coil. So changeover switch also be there. So if you individually open all those lines, means all the current will be passing through this field. Okay, so there will be no current will be the field coil. So total flux will be zero. So it should not be like that. So moderately you have to control as per your requirement. That is known as the field weakening method. Okay, so I think that portions I can cover up to this portion. Okay, so in my next class I can discuss about I can discuss about the other portions. Okay, other important part of the traction. Okay, for the controlling method as well as some important issues. So if you have any kinds of doubts, you can ask me. So again, I can revisit some of the questions. Okay, so please tell me if you have any doubt, or we can conclude our today's session. Okay, you can also put your means in the chat box. You can write your doubt also there. Okay, so we can also discuss about it. So, any of the comments from your side? Okay, so I think most of you have don't have a lot of confusion on it. So I can stop my session. Okay, I can stop my today's session. Thank you.